Hey guys, now we're going to look at a special type of trinomial, and that's when we have perfect square trinomials. So if you don't know your perfect squares, let's list them over here. Perfect square trinomials are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Those are all perfect squares. They're perfect squares because if you multiply a number times itself, you get that number. You multiply a number times itself, and you get that number. So these are perfect squares. And you can take the square root of them very easily. The square root of 64 is 8, because 8 times 8 is 64. So here's your perfect squares. So that's kind of what you're looking for. You have a trinomial, and you're looking at the first coefficient and the last term, and they're both perfect squares. Also, variables can be perfect squares too. So here's some examples of perfect square variables. X squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th. So any even power is a perfect square variable. So the reason why is because you can multiply something times itself. And remember that when you're multiplying like bases, you add the exponents. So 3 plus 3 is 6. So this one would be x to the 5th times x to the 5th. Anytime you multiply something times itself, you get a perfect square. So anything with an even exponent. So that would be x to the 28th times x to the 28th. So that would be a perfect square. So anyway, back to the problem. So you need to be able to recognize that we have a perfect square in the front. So 3 times 3 is 9. X times x is x squared. Then on the back side, and they're both plus, the middle term is plus, so we're going to put a plus here. And then the square root of 4 is 2. And if we square that, we're going to get this trinomial up here. Remember that this is the same thing as, let's check our answer. So 3x plus 2 times 3x plus 2. Squaring is multiplying something times itself. So filling in the boxes. Okay, so our first box gives us our first term. Our last box gives us our last term. And then if you add these two, or you combine those, 6x plus 6x, that's going to give us our middle term. So we have the correct answer. So let's take a look at number 2. This time we have a subtraction in the middle. So the first thing we're going to do is we're going to notice that the first term is a perfect square and the last term is a perfect square. So we would have x, and instead of using a plus, our middle term is minus. So I'm going to go ahead and put a minus here. And then 4 times 4 is 16. So this would be x minus 4 times x minus 4. Let's check our answer. So multiplying, we get x squared. That's our first term. Here we have negative 4 times x, negative 4 times x, and then negative 4 times negative 4 is 16. There's our last term. And then negative 4 plus negative 4x is going to be negative 8x. So we have the correct answer. perfect square trinomials. So here's your opportunity to practice perfect square trinomials. Now let's take a look at the difference of two squares. So what you need to notice here, the word difference means subtract. So we're subtracting two perfect squares. In our example, notice 49 is broken down to 7 times 7, and our x squared is broken down to x times x. And then our 64 is broken down to 8 times 8. Notice there's no middle term, okay? So when there's no middle term, then we don't, we have a plus and a minus. Whereas on the other problem, for example, this one, this would be 3x plus 2 times 3x plus 2, a plus and a plus. This would be x minus 4 times x minus 4, a minus and a minus. But for this example, we're going to have a plus and a minus. So notice we took our 7x, put that first, put our 8 second. And then one of them has to be plus, one of them has to be minus. So let's take a look at number 1. First thing we need to notice is that we have a difference. And we have two perfect squares. And if you don't know your perfect squares, you're going to need to continue to refer back to that list that I gave you. Okay? So let's break this down. So 16 breaks down to 4 times 4. X squared breaks down to x times x. We need 1 plus, 1 minus. And then 49 breaks down to 7 times 7. Now I want you to notice on number 2, 27 is not a perfect square and neither is 3. But this is very important, okay? You need, if you'll remember the notes over the weekend, you need to remember, okay? You need to remember to factor out the greatest common factor. The greatest common factor, if possible. So what you're going to have to be able to do is you're going to need to notice that we can factor out a 3 out of both of these terms. So we're going to get a 3 factored out. So 3 times 9 is 27, x squared. 3 goes into 3 one time. So I had to factor out a 3. Okay. Now you need to look at this and say, can I factor this any further? Well, we have a difference, and these are both perfect squares. So the answer is yes. So 9 breaks down to 3 and 3. X squared, x and x. And the form, as we've seen above here, we talked about one's plus and one's minus. And then 1 breaks down to 1 times 1. And there you go, completely factored. Okay, very important. Remember to factor out the greatest common factor if possible. So number 3, two perfect squares, right? So x squared breaks down to x times x. One's plus, one's minus. Y squared breaks down to y and y. Look at number 4. 200 is not a perfect square, and neither is 8. Okay, so I need to say, well, can I factor anything out of both of these terms? Well, I know that 2 goes into 8 and 200 evenly. I know that 4 goes into both of them evenly. And I do believe 8 goes into 200 evenly. Let's see. 8 into 200. Let's do some work down here. 8 goes into 20 2 times. 4 left over, bring down to 0. 25 times. So yes, so I'm going to factor out an 8. Any common letters? Nope. So 25 m squared n squared minus p squared. Factoring out an 8 out of both of those numbers. Now, do we have a difference of two perfect squares now? Yes. So 25 is going to factor or break down to 5 times 5. M squared is m times m. N squared is n times n. One's plus, one's minus. And p squared breaks down to p times p. And there is your answer. Completely factored. All right. Hope you guys are having a good evening. I'll see you in class.